And when doing this problem, we usually have v0, which is the initial velocity of the object, and also the zeta, which is the angle between the velocity vector and the surface. And it will create a trajectory that is parabola shaped. We can actually prove this, but that will be for later. So just like I said, the object will be pulled down by gravity. So you can have the acceleration component, x component equals 0, and the y components actually equal g because, well, you see here it's being pulled down, and g is obviously perpendicular to the x-axis. So yeah, this is the first thing that you will have. And also, we will split the velocity, the initial velocity, into two components. Right? This is really familiar, right? And so you can also have this component is v0 and cosine theta, and the y component is sine theta. And these two are the first things that you should remember when doing projectile motion problems. And of course, because this is related to motions, we want to find the coordinates x and y of the object. So it's just exactly how we did before. So with x, right, we have x0, which is the initial x coordinate, and the velocity, the x component velocity, which is v0 and cosine theta, and times t, and acceleration is 0, so there's nothing here. So this is x of t, and we also have y of t. It's quite the same. We have y0 now is sine theta here. But wait, we have the acceleration g, and is negative. So this will be a minus and half of gt squared. And this is the second thing that you should remember. And so in order to do that, first we turn t into an equation dependent on x. So t equal be x x0 and v0 cosine theta, and we can put it in the function of y. So we see that y is 0, and now this is times, so we lose this, minus g, and so we can just remove this, obtain a function. Here. plus. And so you can see that this is a quadratic function. And this is why you can see here the trajectory is actually a parabola.